Hello, everyone. Today I'm joined by my colleagues Autumn and Fadak, and we're going to explore the process of ecological recovery in Point Pleasant Park since Hurricane Lee. So to start with a little background information, Point Pleasant Park, a traditional Mi'kmaq gathering place also known as Tukati, or the Place of Spirits, was devastated by Hurricane Juan in 2003. So this massive disturbance took out over 70% of the canopy, effectively resetting the ecological clock and setting the stage for secondary succession, the process by which an ecosystem rebuilds itself after a disturbance that leaves soil intact. So this forest that was lost was an even-aged old-growth stand dominated by red spruce, and our study focuses on its regeneration through secondary succession towards a mature and diverse Acadian forest. The general principles of secondary succession are well established in ecology. However, local factors can have a unique influence on the exact pathway a forest takes. So for an urban coastal park like Point Pleasant is actively managed for public use and ecological restoration, it's critical to document and understand this recovery process. So this leads directly into our question. How and why has the forest community changed in Point Pleasant Park in its structure and composition over the last 22 years? And so to answer this question, we analyzed long-term data from 6 permanent data sites within the park. We tracked changes in total tree density, size of trees, and key community metrics like species richness and Shannon Diversity Index. So based on succession theory, we hypothesized that over this 22-year period, we would observe a significant increase in both species richness and Shannon diversity, signaling a successful progression from a disturbed, simplified state toward a more resilient and complex climax Acadian forest community.
When looking to explore the effects of Hurricane Juan, 6 different sites within Point Pleasant Park were established where the damage was most severe, each site being 20 meters by 20 meters. Data has been collected every year since 2004, with the exception of 2005, 2007, and 2016 due to other hurricanes, and then 2020 due to the COVID-19 pandemic. In some years, less sites were analyzed due to various factors, such as whether where data collection was unsafe. Within each site, all the trees that were more than 2.5 centimeters in diameter were identified and measured using a diameter tape in centimeters at diameter breast height, or 4.5 feet. Non-tree plants were measured using 12 1-meter squared randomly placed quadrants, and all plants within were identified and then measured by how much percentage of the ground they covered. Scatterplots were prepared with this data, which allowed each site within a given year to have its own data point. And then linear regression analyses were performed to show the change over time in Shannon diversity, red maple density, red spruce density, and species richness since 2004.
Hi. So for this part of the presentation, I will focus on how the overall community changed over time and what will happen when it reaches the climax community. To answer this, I look at the Shannon diversity change. It was the best choice because it can show both species richness and evenness. Our null hypothesis states that it will not change, while our alternative hypothesis states that it will increase. Moreover, we used a linear regression analysis to examine the effect of years on Shannon diversity. The result shows a clear positive relationship between the two. This pattern can be further explained in Figure 1. We can see the trend visually that more recent years show higher H prime compared to previous years. For example, in 2025, we have around 1.7 H prime compared to 2015 having 1.3 H prime. Therefore, because of the positive regression slope and the low p-value, we reject the null hypothesis and accept the alternative hypothesis. Overall, these results shows that the forest community has become more diverse over time. For the discussion, these results make sense when we look at how forests recover from disturbance. The increase in Shannon diversity reflects secondary succession as species reestablish and recolonize the area. During secondary succession, some mechanisms allow different species to coexist, such as facilitation. It also helps with increasing species richness and preventing one single species from dominating. However, at the beginning of species richness, early successional species may dominate briefly after disturbance, but diversity increases as species appear in the middle stages. This pattern matches what Burley and his colleagues observed at Point Pleasant Park in 2008. As the forest moves toward a climax community, competition becomes much stronger. A few shade-tolerant species start to become more dominant, and this can cause shonen diversity to level off or slightly decline in the final stages. The stability of diversity will remain until the second disturbance arrives.
A linear regression analysis was performed for both red spruce and red maple, two dominant tree species within Point Pleasant Park, to observe how their densities change over time and what this change can tell us about the changes in successional stages. The null hypothesis for both the red spruce and the red maple state that there will be no change in density over time, and the alternative hypothesis states that there will be a change in density over time. Figure 2 shows that in red spruce, there is a weak but a positive relationship between the red spruce per 400 meters squared and the year, where there is a p-value of less than 0.05 and an r-value of 0.1306. In figure 3, there is also a weak but positive relationship in the red maple per 400 meters squared and the year, with a p-value of less than 0.05 and an r-squared value of 0.1351. These results allow us to reject the null hypotheses and indicate that as time moves forward, both the densities of red spruce and red maple will continue to increase, and that the forest is currently in a mid-successional state. In 2004, a year after the event of Hurricane Juan, red spruce and red maple were two of the most dominant species in Point Pleasant Park. Despite red spruce and red maple being common dominant species in early, mid, and late succession, the forest was thought to be in early succession due to the presence of other dominant species, such as American mountain ash and paperburrs. In 2025, red spruce and red maple continue to be the most dominant species in the forest, but the forest has likely entered mid-stage succession as the densities have increased so significantly. The positive relationship between time and densities of red spruce and red maple indicate that the forest will continue to approach climax community. However, this relationship does not account for the factor of shade tolerance within the species, which is higher in red spruce than in red maple. So as more red spruce grows, it is likely to outcompete the red maples, meaning that with a climax community, there will be a dominance of red spruce and the presence of red maple will decrease. The forest will also likely become more like the original forest, which showed this exact pattern in 1991 of more red spruce than red maple.
So to understand how this variety of tree species has changed, we analyze species richness, which is simply just the count of different tree species present in our plots. So how has it changed over the years? Well, our results demonstrate a clear positive trend. As you can see in the graph on the left side in 2004, it was a very, very low level of species richness, and then on the right side in 2025, it's much, much higher. So statistical analysis shows that time is a strong predictor of this increase in species number with an R-squared of 0.577. In essence, the forest now hosts a greater variety of tree species than it did in the years right after Hurricane Juan. So we know for sure that we've seen an increase in richness, but why? So the massive canopy opening created by Hurricane Juan was pivotal. As you can see in the picture here, it's quite sparse, so there's not much shade. So before the storm, it was very different from this. The even age stand of mature trees likely limited light and resources on the forest floor and prevented a lot of species from establishing. But the disturbance reset this competitive hierarchy, and the sudden availability of sunlight, nutrients, and space created opportunities for those new species to colonize, as well as seedlings of longer-lived species. So finally, what can we predict for the future? As the forest continues its journey toward a climax Acadian forest, we predict that species richness will stabilize, maybe even slightly decrease due to the process of competitive exclusion. As the canopy closes over again, the same thing that was happening before will start to happen again. Shade-tolerant species such as eastern hemlock, American beech, and sugar maple will become dominant, as well as the red spruce and red maple that were there before. There are dense shade conditions that are unsuitable for the pioneer species, like the birch and cherry and aspen. So they'll slowly die out and will return closer to what we were pre-Hurricane Juan, but still more diverse.
To sum up, our result indicates that the Acadian forest is still in a middle successional stage and hasn't reached the climax community. This is because it is an urban park, giving many limitations that contribute to delaying the community from reaching the last successional stage. One limitation is that the spread of non-native species. This can be explained by the red spruce, a shade-tolerant species whose dominant represent in the last successional stage. Yet it is not dominant enough. A second limitation is the high human activities and management action in urban park, which can play a significant role in delaying the progression to a mature Acadian forest. Finally, using a two-eyed seeing approach by applying Micmac technique that emphasizes leaving fallen wood and allowing the nature to regeneration. This can improve and support the Acadian forest community.
In the event of another hurricane, humans should not interfere and try to minimize damage, and the forest should be allowed to reset to an early stage of succession. Because hurricanes are naturally occurring phenomena, and by allowing them to reset, it can become a more diverse forest as it allows species richness, function, and diversity to grow. It's also important that Point Pleasant Park has shown it can make it through an extreme hurricane event and bounce back just as strong. The damage will likely not be as severe as Hurricane Juan, since Point Pleasant Park is making good progress towards becoming a late-stage successional forest, and each year it continues to grow in resilience, which will help it stand stronger against hurricanes.
So for this question, I'll look at how human activities can be reduced to help Point Pleasant Park with reaching its climax community. I will focus on two leading solutions. First, a law can be applied to limit harmful activities inside the park. These laws can help with reducing the repeated disturbance, which is really important because late successional species such as shade tolerance conference need a stable environment to grow. When the forest is legally protected, it speeds up succession and gives slow growing species a chance to reestablish the area. Second, we can use community campaigns to educate people about the importance of succession and what is succession. When visitors understand why the forest needs to be protected after disturbance, they are more careful about how they use it. So overall, combining a strong protection laws with a public education is an effective way to reduce human disturbance and allow the forest to continue moving towards its climax community.
So our data clearly shows that species richness has increased over time since the hurricane. Based on the principle of secondary succession, we conclude that pioneer species are the primary responsible force for this increase. Here's why. In the immediate aftermath of a major disturbance like Hurricane Juan, the ground is laid bare, but the soil remains. So this creates a perfect open conditions for pioneer species. They're the hardy, fast-growing, sun-loving plants like the grasses, shrubs, and the fast-growing trees like cherry, aspen, and birch. And since these species can grow so quickly, they're often the first to colonize a disturbed area. But the rapid establishment doesn't just add a few species, it does change the environment as well. So they stabilize the soil, they add organic matter. This helps make the habitat more suitable for other more sensitive species that are less tolerant when in the future. So the initial surge of richness that we see is the pioneer species arriving and settling, and they set the stage for everything that follows. The climax species, which are typically shade tolerant and slower growing, will become more dominant later in the process. This is kind of what we see in the photo that I've included here. You see these birch and possibly aspen trees. You can't really tell the difference, and they're all nice and high. And you have those evergreens and conifers growing up slowly to take over in the future. And this has caused species drift to eventually stabilize or slightly decrease as the forest reaches a climax community.
And finally, we would like to thank everyone that helped us with preceding the presentation, and special thank to our professor and TA that helped us with the lab.